One of the ways a question can be asked that makes the use of the lateral area of a cone formula a little bit tricky is if instead of given our slant height, we are given the height, which I am showing here with this dotted line. In a cone, the altitude going from the vertex to the center of the circle on the bottom and the radius help form a right triangle with the slant height. We have a right triangle situation, and we can use Pythagoras' theorem to solve for the missing slant height in this situation. R is equal to 6, h is equal to 8. Be careful with this formula because in the usual formula for Pythagoras' theorem, h represents the hypotenuse, and the hypotenuse of this right triangle is the s, the slant height. So we have two different h's, the h for the height or altitude, and the h for the hypotenuse, which is in this case is the slant height. My a and my b are going to be the radius and the height, the 6 and the 8. So I plug these in, and we will solve for the hypotenuse. 6 squared is 36, 8 squared is 64. So 36 plus 64 is 100. And therefore h is equal to the square root of 100, which is 10. And because we were dealing with meters for our distances, the hypotenuse of this right triangle is 10 meters in length. That means our slant height is 10 meters. Now we can plug the slant height and the radius into the formula for lateral area of a cone and answer our question. Pi is 3.14. Radius is 6. Slant height is 10. We have 3.14 times 60. Our answer is 3.14 times 60, which is 188.4. Because we were dealing with meters and lateral area is an area, the unit of measure will be meters squared. Another way in which a question that asks you to use the lateral area of the cone formula can be made a little more tricky is represented in this example here. We are asked for the lateral area, and we are given the slant height, but we are not given the radius. Instead, we are given the area of the circle at one end of the cone. We just have to remember our formula for the area of a circle can be used, given that area, to find the radius. Plugging this value into this formula, we get 19.625 equals 3.14, our value in these examples for pi, r squared. Dividing both sides by 3.14, these cancel, r squared is isolated, and is equal to 6.25. But we don't want r squared, we want r. R is going to be equal to the square root of 6.25, which is 2.5. And because we were dealing with centimeters squared, the radius is 2.5 centimeters in length. Now we can plug it into the lateral area of a cone formula and answer a question. Lateral area is equal to pi times radius 2.5 times slant height 9, which is equal to pi times 22.5. The result when you multiply 2.5 by 9. And that means our lateral area is equal to 70.65. Again, it is an area. Since we were dealing with centimeters, the area will be centimeters squared. The lateral area of this cone is 70.65 centimeters squared. Remember that lateral area includes the area of the slanted outside part of the cone, but does not include the area of the circle at the bottom.